Welcome to the course Business Analytics and Data Mining Modeling using R. In the previous lecture, we started our discussion on multiple linear regression, and we discussed the theoretical, most of the theoretical part of it, and we were doing an exercise using RStudio. So let's start from there. So let's open RStudio. So, last time we were able to produce the results of the regression analysis. So, we will going to reproduce the same, and then we are going to pick up our discussion from the same point. So, let us load this library, the file, the data set that we have been using. Let us remove any columns. Let's create this variable age. Then we don't want, let's take a backup, and then we don't want few columns, so let's eliminate them. Then let's also change this variable type. Now in the previous lecture we also eliminated few points, so let's again do the same thing here. Now let's also do the partitioning. So we were discussing the results of this regression analysis, so let's come to that part. So here at this point we were discussing the results of this particular regression regression analysis, and we talked about the fuel type variable being the categorical variable, the factor variable in our environment, and how in the results we see these two categories, fuel type diesel and fuel type petrol. Similarly, for transmission, which was converted into a factor variable, so this we can see as transmission 1 is there instead of transmission. So how this is happening and why this is happening, right? So as discussed in the previous lecture as well, that any variable, any categorical variable which is having data in textual format, string format, it is going to be automatically treated as a factor variable in our environment. Any variable which is in the numeric, which is having labels in 0 or 1s or some numeric forms in the numeric code form, so that will be treated as a numeric code. So therefore we would have to convert that particular variable into factor variable, so which we did for the transmission. Now once you have converted your categorical variables as factor variables in our environment, right? So then another thing that we were discussing in the last session, that for a particular categorical variable having many categories, many labels, right? So let's say the many classes that it has, C1 to let's say C1, C2 and C3, right? So it will have so we talked about dummy coding. We talked about that we will have to compute 3 dummy variables if there are 3 labels, and then we also talked about that we will have to include only D1, let's say only D1 and D2, only 2 of the dummy variables. In this case we have 3 classes, we have 3 classes. We talked about that we would have to create 3 dummy variables. This is the part that we were discussing in the last lecture, and then 2 dummies will have to incorporate in our model. The remaining one would be the reference category. So the remaining class that is there, that class C3 would be the reference category, and we talked about that any results, any interpretation of the results that we get for these dummy variables for this categorical variable, it has to be, the interpretation has to be with respect to this reference category, right? So we also talked about that in our environment. We also displayed this, that generally if you the labels, the way they are created, labels, if it is textual labels, text labels, right. Then they would be in alphabetical order. So the ordering of those labels would be alphabetically. So if you don't change the labels, so the default. So for example, in this case we had CNG and diesel and then petrol. So therefore this would be the ordering of the labels for the categorical variable, and by default CNG would be treated as the reference category and the remaining two would be part of the model. So this is what has happened in the results. You can see that fuel type diesel and fuel type petrol, they are part of the model. They have the regression coefficient as being displayed in the output, and the CNG has become the reference category. But if you wanted petrol to be your reference category and you wanted CNG and diesel to be incorporated in your model, then you would have to change this ordering in R. You would have to change this ordering in R environment, right. So there is different functions that are available to perform this ordering. So this particular change in ordering will come in coming lectures, where we would be requiring where we'll be in such a situation that we would be requiring the change in labels. So relabel is the function that can be used in our environment to actually perform this change in labeling. We will do this using an exercise in coming lectures. You can see in the help section, relabel, reorder labels of factor. So this particular function can actually be used to change the labels, change the ordering of these labels, and therefore whatever labels comes first, that would actually be the after changing. Let's say you wanted petrol to be your reference category, you can have an ordering like this, and now once you have changed this ordering, then petrol is going to be your reference category and CNG and diesel would be part of your model. So depending on the task at your hand, depending on the kind of interpretation that you require, depending on your requirements of reference category, which particular class you want to treat as reference category and which particular classes you want to have in the model, so that you will have to decide, and accordingly you will have to change it. Similarly, if your labels are numeric codes, which is generally the case, so they would be 0 or 1s. For example, if we are talking about if it's a 2 class case, if it is more than 2 class case, then the labels could be anything depending on the way data set is presented to you. Labels could be in these numeric codes, so they could be in any ordering, because numeric codes that if they are being used, they could be in any ordering, right. So there also, if you want to change the the labeling there in our environment would again be in the increasing value order, right. So for example, if you have 1, 2, 3 and 4 labels, so the labeling would be 1, 2, 3 and 4, and therefore the class 1 would become the reference category and the others would be included in the model. So therefore, if your task requires you to have class 2 as reference category, then you will need to change this order, right. So again, same thing you can do using the relabel command. So you will have to change these orders, and we will be doing in the coming lectures, we would be doing such an exercise, and then your ordering would change and your reference category will become 2, right, and other categories would be part of the model, part of the results that we produce, right. So this is mainly about the categorical variable and the labelings and the reference category that we need to take care. Now another difference between R and other commercial softwares, other statistical software, is that in other statistical software you might have to perform your dummy coding explicitly, and then bring that those variables, dummy coded variables, into your model. In R, if you are having text labels, or once you have declared a variable in R environment, once you declare a variable as factor variable, that is nothing but the categorical variable, then most of the packages, most of the functions that are available, they take care of the dummy coding. So you don't have to explicitly convert your categorical variable into these dummy variables, zeros and ones, as we talked about in the previous session, presence or absence of that thing. So this part we have discussed in the previous lecture. So you don't have to do this dummy coding 0 and 1 in R environment if you have converted your variable into a factor variable. In other commercial statistical software, you will have to perform this dummy coding on your own. There are many software provide specific utilities for the same. So therefore, it is quite easier even for in those softwares also to perform this dummy coding. But you will have to perform dummy coding first, and then you will have to pick your variables, right? And then you will have to include them in your model. That is how it will happen in other softwares. In R, you just need to convert your variable into a factor variable, irrespective of whether the labeling is text or based or the numeric codes based. Once you convert them, most of the things would be taken care of. Only thing that you would be required to change is the reference category. Now let us look at the results that we have. So as we discussed, the LM function, the formula that is being passed here, and we can also see some the descriptive stats about residuals, and then we come to the coefficient part where we can see the intercept, then the fuel type diesel and fuel type petrol. But we can see that neither of this fuel type are significant. Significance, how do we see in the results? You can see at the end of this particular results, you would see asterisks there. Now these if any of the variable, any of the row has asterisk against it, then that particular variable, that particular predictor has a significant relationship with the outcome variable. So now there are different levels of significance. So you can see between 0 and 0.001. If your p value, which is the last column here, this is your p value. So if this p value, the concept of p value we have discussed in supplementary lectures, so you are recommended to watch those videos. So if your p value is lying between 0 and 0.001, then that is indicated using 3 star. If your p value is lying between 0.001 and 0.01, then that is indicated using 2 stars. If your p value is lying between 0.01 and 0.05, so that is indicated by a single asterisk, right? If your value is between 0.05 and 0.1, so that is being indicated in this case is dot, otherwise it would be a blank. So we are generally so these ranges actually also signify the confidence interval. For example, if we have single asterisk here, that means the value is between 0.0, if that means the value is less than 0.05, that actually also signifies that we have accepted we are working with the confidence interval of 95%. If the value is less than 0.01, that means 2 asterisk would be used. So therefore we are looking for the relationship with 2 asterisk or more, and therefore the 99% confidence interval is being used. If it is 3 star, then it has to be 99.9%. so if the value is less than 0.001, then we are working with the 99.9% confidence interval. Sometimes people might also pick even the 90% confidence interval. In those situations, the p value is going to be less than 0.1. So depending on the acceptance of the confidence interval that you want, then the level of acceptance of your error that you can select the significant relationship. For example, the most typical confidence interval that is generally used is 95%, and generally we are looking for relationships which are having 3 star significance levels. So if we look at the results, any particular rows belonging to different variables, the variables that we have in the model, if there are no such asterisks as discussed, no such codes, so that means those are insignificant relationships. So the significant relationship that we can see is SR price, that is showroom price, having 2 asterisks in this case. So therefore having being significant relationship at 99% confidence level. We look at the KM also, so this is 1 asterisk is there, so therefore this relationship is significant at the level of the 95% confidence interval. Other relationship, if we ignore the intercept term, then the main predictors that are there, others seem to be significant. Please also bear in mind that we are dealing with a data set that is just having 75 observations, right. This is a quite few number of observations in this case. So therefore the results are not that much stable, and therefore the relationships that we see, the significance of relationship, only 2 of them are being significant. That will also change depending on the partition that we select. So at this moment the partition that we have created 60%, 40%, and the observation that have been randomly selected into the training partition, that are in a way determining the relationship, the significance of relationship and all that. So therefore it is generally advisable to have a much larger data set, so that we can overcome the problems that could be there due to smaller sample size. So currently what we have is the smaller sample size, and it might not be reflective of the true relationship between the outcome variable of interest and the set of predictors that we have. Now other things that you can see in the regression results is the estimate, this is regression coefficients for all these variables. So we generally also look whether these estimates, how if something is less than the value of residual standard error, right. If something is less than that, then probably even if those coefficients are having significant relationship, right. We even drop those variables. So some of the insignificant variables that we see, we can easily drop them to reach our final model, and even some of the predictors which are having this particular estimate, the regression coefficient less than the residual standard error, that is also a candidate for elimination. That predictor also could be candidate, because those variables would reduce, dropping of such variables would reduce dropping of insignificant variables, and also variables having, even though having significant relationship but very small regression coefficient or small estimate as in this column, that would improve the that would actually reduce the variability in the prediction errors, and which is the desirable thing for us. So this particular column gives us the regression coefficients for different variables. So for example, in the SR price, you can see 0.2 is the value, and for KM we can see minus 0.02 is the value. Then we have standard error as well. So for all these relationships, standard error has also been given, and the t value and p value is also given, based on which we can find out the significance of the relationship as discussed. Other statistics that are available in this results are residual standard error and the degrees of freedom. We can also see the multiple R square, which we will discuss coming lecture. So multiple R square captures the proportion of explained variance. So in this case we can see 67% of the variability in the outcome variable is being explained, the value being 0.6747, so 67% the variance is being explained. We also have the adjusted R square. There is some difference between multiple R square and adjusted R square. We will discuss this also in this lecture or coming lecture. You can see adjusted R square value is slightly on the lower side, that is 0.6025, that is about 60% lower than multiple R square value. So we will discuss this why this value is lower, and generally we prefer to look at the adjusted R square value. This is considered to be a much better criteria to check the performance of the model. Especially in statistical sense, we are generally looking for these R square value, because there our idea is to find a model which is best fit to data. So therefore R square values, whether it's multiple R square or adjusted R square, indicating the proportion of variability that is being explained by the model, thereby indicating the fitness of model to data. Therefore we always look for higher value, and then adjusted R square being a better indicator than multiple R square. So we always look for the adjusted R square value for different models, right, and different variation that we could have for this particular regression analysis that we are doing. So we look for the model having higher adjusted R square value. Then we have F statistics, which we covered in our supplementary lecture. So these values are also there, indicating the significance of the overall model that we have. Now let's look at few more measures. So these measures that we are going to compute now, they are mainly for goodness of fit. So you can see that we are trying to find out the this residual value, right, for this model, and degree of freedom for the degree of freedom for the residual, and then we have R square value, and then the sigma value, right, and then the residuals sum of square. So all these values we are going to compute. So let's execute these codes. So these are few more statistics that we can discuss. Residual DF, this was all 36 is there. Multiple R square value, that is the same that we discussed before, 67. Standard deviation estimate is also there. Residual SS is also there. Residual sum of square is also there. So sometimes we also like to compare residual SS value if there are more than one model, if there are many candidate models. So some of these numbers we would like to compare, and then we can decide find the most useful model or best performing model. Now let's test the performance of this particular model on test partition. So we are going to score the test partition first. So you can see the function that we are going to use is predict. So predict function, it's quite a generic function. So for many different techniques, for many different methods, this particular function, just like summary function, this is available, so that on any new data so that we are able to score any new data using the model that we have just built. So for example, mod is representing the model that we have just built using training partition. Now we are going to score this data, that is test partition DF test. You can see that we are eliminating the fourth column, which is actually the outcome variable. So we don't need that, right. So it is the model which is going to be scoring this particular data set having just the predictors information. So just to clear that we don't need the outcome variable, we are trying to predict the outcome variable, and therefore this particular column has been eliminated. So let's score this test data set. Now we can also compute the residuals for test data set, the error values for test data set. So now you can see that outcome variable, this is representing the actual values. Now we can subtract the predicted values and find the errors or residuals. Now let's create this data frame, and let's have a look at the first 6 observations. So you can see the actual value and the predicted value and the residual. So for first 6 observations out of the 75 total, we can see these 3 values: actual value, predicted value, and the residuals. Now, if we want to, as we discussed that we wanted to, the main idea being why the main idea behind scoring the test partition is we wanted to compare the performance of our model in training partition with test partition. So, for this we are going to require this particular library R minor. So, this particular library has functions which can be used to compute various metrics that we talked about in our previous lectures on performance metrics. So, let us load this particular library. Now, m metric is the function that is used. So, in this particular function the actual values are the first argument. So, you can see df train price is the first argument. So, here you can see we are also computing the matrix on training partition as well, and then the fitted values that are predicted values, right. So, that is the second argument, and then the third argument is a character vector indicating the matrix that we want to compute. So, in this case we want to compute SSE, that is sum of squares error, then RMSE and ME mean error. So, all these matrices, these three matrices specifically we want to compute. Now, once this has been done, you can see we are using another function print, that is just to, because we are not interested in the actual value till the last decimal point, we would just be interested in few decimal points, and because the main idea is to compare. So, print function I am using and rounding off the results that we have got in the previous line, and we are restricting the numbers to 6 decimal points, right. So, let us print these numbers. So, these are the numbers, the value for SSE, RMSE, ME, and if you look at the previous value, the residual SS, that 66.98 that we had, this is nothing but SSE. Again the same number is coming there. The new matrix that we have computed is RMSE and ME. Now, let us look at the our values on test partition. So, again we are going to call this function m metric, and you can see first argument now for the test partition. So, the actual values, and then the mod test, these are the predicted values which we have just computed using the predict function, right. So, this scoring has already been done, and the same matrix. So, we want to compute the data for the same matrix, and you can see the numbers. So, in this case you can see that the SSE value that we have is even lower in the case of test partition. So, the model seems to be performing better in the test partition in comparison to training partition. So, this is for because we are having a smaller data set. So, this seems to be more because of the chance thing. So, it is always advisable to have a larger data set, so that we are more sure about the results that we have. So, in this particular instance, the exercise that we have done, our model seems to be performing better in new data in the test partition. If we look at the RMSE value, that is also on the lower side. So, RMSE value is a much better indicator, as we have discussed in the previous lecture, because it gives us the number in the same unit as the outcome variable. So, we can see that RMSE value for the test partition is also on the lower side in comparison to training partition. If we look at the ME value, so we can see that in the training partition the ME value is 0. So, therefore, the on an average level model is neither over predicting nor under predicting for the training partition. But if we look at the ME value for test partition, we can see that this is negative. So, on an average level model is under predicting the values. So, so from this we can see the results that we have. We can say that the model is robust, model is giving stable performance or even better performance, but however the main caution being that this exercise that we have done is on a smaller data set, and therefore the results also depend on the partitions that we created and the observations that are selected on those partitions. So, therefore, it is always advisable to have a larger sample size and then trust your results. So, we will stop here. and we will continue our discussion on multiple linear regression in the next lecture. Thank you.